So, welcome to another episode of creating an operating system from scratch. In the last episode, we did some keyboard inputs from user. We did a bootloader. We did a kernel. We did a file system. So, if you haven't looked at yet, I suggest you to take a look at that video before you're watching this episode. So today we have here formed some stacks. So we have those two files. We have bootloader file, which I'll put the link again in the description. You can just copy and paste that. And we have our kernel file, which just have some stack formed. So what we're going to do today, we're going to make an system work like like terminal on the Linux. Like we'll make TTI, so the user can interact with that operating system. So when you type some command like date or something like that, the operating system will output the date or something like, or some message or whatever. We are just creating like TTI or a terminal. So like that, when you type a date in a terminal, you get date. Or you just echo some message, you have that message here. So we are going to make something like that. First thing we are doing here, we're going to clear the screen. So to do that, we're going to move AL 3 age. So move age 0 and interrupt 10 age to do that. After that, we are going to make some message. We want to print some message just to test it out if everything works fine. So to do that, we are going to create and flag like a message. So msg db hello world. That's it. So to print that message, we have to create a print function. So you can call it whatever. I'm going to call it write. So you can call it print or whatever. The first thing we're going to do, we grab a byte from the SI register, and we're doing that like with this instruction. Then we have to decide if it's logical or AL by itself. So to do that, you're writing or AL. If it's done, if we read all the data from SI, we are going to go to done. That is flag just returning, just calling the return function. So it's just returning, and we're making some loop here inside that write function that will load character by character. While it's happening, just go to write unless it's all read. So we did that. Now to print some message, we're going to move message to si, then we're going to call write function, and that's supposed to be that. It's supposed to work. Let's test it out. So I'm here in this folder. I'm going to clear everything so you just see how I'm building this. So first thing we are going to make, we are making file system. So we're calling whatever we want. We'll call it OS. You can type whatever name you like. .flp. Actually, I have to do that. 100. That's the size. That's the minimum size you have to type. We have that. Now we are compiling the our bootloader. And voila, we have our bootloader compiled. Now we are compiling the kernel the same way we did with the bootloader. Sorry for that. And we are copying the bootloader on the file system. We're making directory. We're calling it tmp-loop, and in this directory we're going to put our files, our kernel in this case. So we're mounting this folder. And we're copying, let me first mount that, and we are copying our kernel to tmp-loop. Then we are mounting that. Sorry. And we're making ISO file of that. Here, and then we are testing it out by typing system by QEMU virtual machine. Sorry for that. And we are having our hello world, but it's disappearing because we haven't stopped everything here. I'm just have to write here just to stop it from freezing out. So let's remake everything. We remake kernel. Now we have to delete Now we have our message here successfully wrote, and everything works fine. As you can see, there could be any message, anything you want. That's the printing on the screen, and you can just run it in real machine without any operating system needed. Now the second thing we're testing out, we're going to put some color background here just to test if everything works fine. And to do that, we are doing move age 9 age, move cx that just to sorry for that. And then we're choosing some color. I'm here going to choose a blue color. That's 10 age. Just interrupt 10 age, and it's going to be blue background. So test this out, we have to recompile everything over and over again. So let's run it the same way. Actually debugging cdrom w+orphan-labels, and we have a blue background. If you just change this number, if you type 3, you will get cyan color. So I'm going to remake everything, and you can see that it's a cyan behind that. So, and we have our text here. If you just delete those lines of code, it will be all black again. As you can see, it's all black. Now if we did that, we're going to make we're going to make a TTI or terminal like program. So main loop will happen every time while this operating system works. So the message here we're going to do is prompt and now let's roll the main loop. So move to si prompt like we did with a message, and then call write function, so it will write prompt if so we have to form some buffer for the inputs. db0, so when the user types something, we are putting that in the buffer by moving to di buffer, and then we have to make a function to get that string. So get string, and then first thing we are XOR CL or CL, and creating a loop to load loop to load from the buffer So we are waiting for the key press here. We are making like in the previous episode we created keyboard inputs. We are now doing it again, but something easier. Call that. So when we moved into the buffer, we're at that point we're calling get string. Now we have our string in buffer. So now move ci, if we're moving to ci buffer, and then checking if there is no anything written in the buffer. If user just press the enter from the beginning, if size of the buffer is 0, then jump to the main loop. If it's not the case, move ci to the buffer, and then we're going to print that message. Again, everything from the buffer we're going to print, just test it out if everything works, and then just from that we are going to jump to the main loop again. Let's see if it's working now. Again, compiling. It's not the main loop, it's a loop. Not the main loop, it's a loop. Loop here, loop here, and here. It's also loop. Let's recompile and test again. Everything working fine. We have our cursor blinking, but why we can't type any message? We don't see in the screen again. We forgot to add. Before that, we have to add here move age E to print out the character while typing it. Let's recompile. And now you can see everything working just fine. So if we type nothing, we have nothing here. And then if we type hi, we're having a message over from the buffer writing again. So we did reading from the keyboard, writing into the buffer, and now we have to implement function to check what is the message what is the command we typed. So what is in the buffer. So when we checked if it's not null, we are having to do some comparisons. So we are to compare the strings, we have to write a function string compare, like in the C it's calling strcmp, so we are calling the same. So again we have some loop, not the main loop, again loop. In that loop we are moving to AL, we are moving CI, but data bytes, then grab byte from DI, because we have in the CI and the DI the strings we are trying to compare. Then if AL, so if those strings are the same to BL. If they are not same, if they are not same, we are jumping to not equal. So not equal. If it's not equal, then clear the carry flag, CLC. I'm pretty sure I typed that, and then return. But if they are the same, then if they are equal, then go to done. Enter done. Done should set the carry flag, so stc for setting a carry flag, and then return. And after it's returning there, we have to increment di, then increment ci, and then again while it's looping, while it's loaded all the bytes from the both of the registers, it's looping. So here what we are comparing right now, we are comparing if the user typed, for example, so we are moving to SI buffer again, and then we are moving to DI our message, which will be a high message, but we have to make down there where our flags for the messages to implement that message that's like variable. So then we're calling the comparing function, and if they are the same, then it will jump to print hi message, so we're going to implement it here. Into si hi message and call write. But if it's not, then jump to main loop. And then here again jump to main loop. We have to get down there and add hi message, hi. So if the user type hi, then hi answer will be hello. Then we're just have to put a db here. We just have to change here the writing message. So here we are checking, we are putting the buffer, we are putting the message, we are checking if it's the same as the buffer. We are calling strcmp function. If it is, it's going to hi, and hi will print our answer, hi answer, and then calling write function, and then going to back to main loop. If it's not, it's just jumping to main loop and then just checking out if we type. Let's run it again and then write a message. It's nothing happening, and if we write hi, it says hello. So this is how TTI works, or terminal, and this is how we are implementing our first operating system that actually do something like writing messages, answers to us, and that's all. So thank you very much for watching. Hope you like this video. Don't forget to subscribe button if you like that, and let me know in the comments below what you didn't understood. I'll be glad to help you. So thanks again for watching. Have a nice day.